In this lecture, we're going to see how we can declare and use pointers in our C++ code. In the last lecture, we said that a pointer is a special kind of variable that can store addresses to other variables in our C++ code. And we have seen a slide like this to drive the point home. Now we're going to see how we can actually use pointers in our code. Here is a simple example of how you can declare a pointer variable in your C++ code. You say int. You put a star after the type to mean that this variable is not a regular variable like we have seen before. It is a special kind of variable that is going to store addresses to other variables. And here I have to say that you have to be really careful and only store addresses to valid types of variable in your pointers. For example, this is a pointer to int. It can only store an address of a variable of type int. For other types, if you try and put in their addresses in here, you're going to get a compiler error. Down here you see we have another example, and it's called p fractional number because it's a double. And you see that our pointers here are initialized using braced initializers, and this is going to initialize the pointers with a special address that really denotes that these pointers are not pointing to anything yet. Okay, you can also say that explicitly and put null ptr inside, and this is going to mean that these pointers are not pointing anywhere. You can't really use the values at the addresses where they point. This is the message here. Don't use pointers that contain null pointer. All pointers on a given system are going to have the same size. For example, if you have a pointer to int and a pointer to double, they are going to be the same size because they really store the same thing. They store addresses to variables, and addresses to different variables, even if they happen to be of the same type on the same system, are of the same size. That's why all the pointers you're going to use in your code are going to have the same size. And this is something you should keep in mind. And here is a simple example to really play with that. We have a size of int printed out. We have a size of our pointers printed out, and we're going to compare these things when we get to Visual Studio Code in a minute, and you're going to see that all pointers are of the same size. A question I get from many people is if the position of this star symbol really matters, and I have to break it to you, it doesn't. But I prefer to put it on the left. Some people prefer to put it on the right, but definitely don't put it in the middle. I've never seen anybody do this, but it's going to work. It's going to be legal C++ code. Another thing I see people do, which is really confusing, is to declare your pointers on the same line and do a comma like this. This is really going to be confusing. And now I want you to guess and see what is happening here. Is either int var a pointer or it's a regular int? I want you to keep this in mind. I'm not going to tell you. We're going to try this out actually in Visual Studio Code, and we're going to figure this out together. But now I want you to try and think about it. We're going to leave this question unanswered, and we're going to answer it in a little while. But for now, don't really do this because it's confusing and it's going to make your code less readable. If you have to do something like this, make sure you just put them on different lines and it's not going to be confusing. For example, if you look down here, you're going to know that p number 7 is a pointer, other int var is a regular int, and there is no room for confusion this time. Use code like this and don't put things on the same line like we have on top here. Okay, now we have seen that we can declare and initialize pointers with null pointer. Now is the time to see how we can put actual data in those pointer variables. Here we have a variable which is called int var. It is of type int and its value is a 43. We can also set up another pointer variable, int pointer. Its name is p_int, and we can initialize it with the address of another variable. And here is a new operator we haven't seen before. This ampersand variable here really means the address of this int variable. That's what we mean here. So we're going to initialize this p_int variable with the address of int variable, and this is how we do it. If we go down here, we print int var, we're going to get the value printed out. If we print the pointer directly, we're going to get the address of this little guy printed out on the console, and we're going to see it. Okay, so this is how you can store things in your pointer variables, and what you have to store in has to be an address of another variable. Down here you see we have another variable called int var1. Inside we have a 65, and if you go down here you see that we are storing something else in our pointer variable here. We had in the address of int var. Now we are putting in the address of int var1 using an assignment operator, and this is something you can definitely do. It's legal C++. It's going to work. If we print it out, we're going to get a different address printed out. This is how you can store values in your pointer variables. Again, you can't cross-assign before different pointer types. Here we have an int pointer which is called pint1, and we have a double variable called double var. We can't take the address of double var and store that in pint1. This is going to be a compiler error. The variables whose addresses you store in pint1 have to be of type int. Again, the basic idea is that a pointer is really a special kind of variable that is going to store addresses to other variables. And if your pointer is a pointer to int, the variables whose addresses you can store in this pointer to int can only be ints. If you try and put in doubles, you're going to be in trouble. You're going to get a compiler error, and it's not going to work. Now we're going to head over to Visual Studio Code and actually play with these things. Here we are in our working directory. The current chapter is pointers. The current lecture is declaring and using pointers. We're going to grab our template files and put them in place. So put them in our project here, and we're going to open this in Visual Studio Code. The first thing we're going to see is how we can declare and initialize pointers. And we're going to use a pointer to int as a first example. We're going to set up an int pointer, and we say int star. We're going to give it a name. We're going to call this p number, and you can leave it like this uninitialized. But it is really advised to always initialize your pointers. So we're going to do that with a braced initializer, which is going to do that for us. This is going to implicitly initialize it with a 0 equivalent of pointers, and that happens to be null pointer. So we'll initialize. Okay, so this is what we're going to initialize with, null pointer. We say null ptr, and this is how you should do things. We can also do a pointer to double. Why not? Let's do double pointer. And we're going to say fractional number, pointer to fractional number. And we can also initialize this with null pointer implicitly. And once you do this, the program is going to be legal. If we try to build it with GCC like we always do, the build is going to be good, but we don't really have any useful thing we can see if we run this program. We are just getting started. We will get to see things later. For now, just understand that p number is a variable we have in our code. This variable can only store addresses to other variables that happen to be of type int. If you try and store in an address of a variable which is of type double, for example, or float, you're going to get a compiler error. You shouldn't do that. The same for p fractional number. It can only store addresses to other variables which happen to be of type double. Keep this in mind. We can also explicitly initialize with null pointer. So we can say int pointer and say p number 1. Why not? And we're going to explicitly use null ptr like this. And this is going to work as well. We can also say p fractional number and say 1, why not, and say null ptr. This is going to work. This is something you can do. You're going to see that if we compile this, the compiler is going to be happy with this. The build is good. Okay, now you know how you can declare and initialize your pointers. Now we want to see that pointers to different variables are actually of the same size on whatever system you are working on. It's not consistent across operating systems or even systems, but it is guaranteed to be of the same size on the same machine. I am going to go down and put in a piece of code that is going to show us all of these things on the console. And I am going to click on this file icon here and give ourselves some breathing room so that we can see the entire thing here. If you look here, we are printing the size of int. We know that this is going to be a 4. Size of double, this is going to be an 8 on our system here, but we don't know what the size of a double pointer is or the size of an int pointer. And we're going to see that in a minute. Here you see that we are also using the pointer variables immediately. This is something you can do. You see that Visual Studio Code is not complaining. And we can go on top here and build with GCC. Let's do that. The build is going to be good. Now we can open up a terminal and actually run this program here. We're going to clear. If we do dir, we're going to see that in our directory here. So you see that we have rooster.exe. And we can run this, and it's going to say size of int is 4, size of double is 8. This is expected, but pointer types are of size 8 on my system. They occupy 8 bytes in memory. So it doesn't matter the type we are pointing to, a pointer to it is always going to be 8 bytes in memory. This is something you should really know and keep in your mind. Another thing we have said that I want to play with right now is the location of the star symbol. Some people say you should put it on the left. Some people say you should put it to the right. I don't really think any of these things matters. I prefer to put it to the left, but if you put it to the right, it's also possible. It's going to work. You see that even if you put it in the middle here, which is really crazy, the compiler is going to take this. We can run the task to build this to make sure the compiler is really happy, and you see that there's no problem. The compiler is going to accept this, and we are going to build successfully. If you put your declaration on a single line like this, what is other int var going to be? Is it going to be a regular int variable? Is it going to be a pointer to int? We don't really know now, and I don't want to tell you. We're going to find out together. So what we're going to do, we're going to print the size of these things. I am going to go down here and put in the code and come back in a minute. Here is our code typed out, and we're going to see the size of these things. What we're going to do is run the task to build with GCC as we always do. Let's clear properly and run Rooster. And you see size of P number 5 is 8 because it's a pointer. Size of other int is 4, and the same applies to the second line here. So from this, we can tell that other int var and other int var 6 are not pointers. They are regular integers, and this can be really confusing. So to avoid this confusion, I would advise not to declare your things when you have pointers inside like this, because that's going to be really confusing. What you can do is put them on separate lines and do something like this. So here it is very clear that P number 7 is a pointer, other int var 7 is a regular int variable, and there is no room for confusion with this way of doing things. So make sure you put things on separate lines like this, and you're going to be fine. Now what I want you to see is that we can actually store data in our pointers. I mean valid data that is not null pointer. In this case, we're going to set up a variable, a regular int variable. It's going to store a 43 inside, and we're going to set up another pointer and initialize that with the address of this int variable. And this is going to work properly. What we can do now is print the int var. We're going to print it out. If we try to print the pointer, we're going to get the address of this int var in memory. And this is something you need to see with your eyes. This is the first time we are printing out an address that is stored in a pointer, and we're going to see that on the console here. What I am going to do before we build and run this, I am going to comment out everything we've done before because our console is now cluttered. So let's come and comment out everything. And let's go down again. Now if we print, we're going to see these two statements, and that's going to be easier to follow on the console here. The build is good, so we are cool. Let's run Rooster. And the var is 43, and its address in memory is this number here. It is in hexadecimal. So this is the address in memory, and we can print that out and see what it is. Okay, so this is really cool, but we can also change what is stored in our pointer here. For example, we can set up another variable, call it int var1, and change pint, which is a pointer, to contain the address of this new variable. And we can do that. Now, if we print pint, we're going to see that it contains a different address, and we can do that. So let's build with GCC again. We're going to go down and clear and run Rooster, and we're going to see that now we have a different address. The one we had ended in DE4, now we end in DE0. These are different addresses, and we are storing different things in our pointer. This is really cool. You can do something like this. And the next thing we want to see now is that we can't cross-assign between pointers of different types. And what I mean here is that, for example, if we have two variables here, one is a pointer to int, it is initialized with null pointer, and we have another variable which is a double var, it's going to be of type double, and we can't do something like pint equals address of double var. You can't do something like this. If you do it, you're going to get a compiler error, and you see that we have squiggly lines in Visual Studio Code. This is a good indication that something might be wrong. If we open the Problems tab, we're going to say a value of double pointer cannot be assigned to an entity of type int pointer. So this is not something you can do. If you do this, you're going to get a compiler error. Be aware of this. Visual Studio Code has warned us enough, but we can also try and get a clear compiler error by building this with GCC, and we're going to get basically the same thing. You can't cross-assign between pointers of different types. We are trying to assign a double address into a pointer to int, and this is not going to work. So let's comment this out because we don't want this compiler error. Now you know this. And before we close this lecture, I want to mention what is called dereferencing. And that is the act of reading something through a pointer. So if we have an address in a pointer, we can go through that address and actually read the value contained in that address. And we can do something like this. So if we have, for example, an int pointer, let's call it pint2. Do we have a variable like this? So let's say we initialize this with null pointer, and we have an int variable, and this is a 56, for example. And we do something like, we do say pint2. We're going to make it contain the address of int data. This is something you know you can do now. Now we want to go through pint2 to read what is contained in int data, because pint2 contains the address of our integer here. So what we can do, we can do stdcout and say value. And the syntax we use in C++ is like this. We say star and we say our pointer variable. We're going to say pint2. And now if we run, we're going to get the value here printed out. Okay, now if we try to build, we're going to build fine. Let's try with GCC. The build is good. We can clear so that the errors from a previous run are cleared out. You see, the build is good. We can now run Rooster, and we're going to see that value is 56. We are successfully reading the value stored in the address pointed to by our pointer here. And this is the syntax used, and this is called dereferencing a pointer. We are basically reading something stored in the address of a pointer. This is what we mean here. And this is really all we set out to do in this lecture. The lecture turned out to be lengthy, but we had a lot of ground to cover. And now I hope you have a good grasp on how to declare, initialize, and use your pointers to do all kinds of crazy things. We are going to stop here in this lecture. In the next one, we're going to learn a little more about pointer to character types, because they are also special. Go ahead and finish up here and meet me there.